Notice that this loop counter here is not only there to control how many times the loop should iterate, it can actually be used inside the loop as a variable. Let's see how. Say for example you want to change the warning message to actually say the number of the warning it's displaying, like warning number 1, warning number 2, 3, 4, and 5. This can be done by simply concatenating our variable I to our warning message here. Everything else can remain the same. Let's trace this program and see what's going on. If we call our function raiseAlarm by passing in the value 5, so number of warnings is equal to 5. We start by initializing I to 1, and then we compare I to the number of warnings. If it's less than or equal to 5, which is true, so we step inside our loop. First thing we're doing is we're printing out warning number concatenated with I. In that case, I is equal to 1. So this is going to print out warning number 1. We've reached the end of the loop, so what's the first thing we do? We increment I, making it 2, and then once we increment I, we go and do our check. 2 is less than or equal to 5, and that's true, so we step inside our loop. Now I is equal to 2, so when we concatenate it with warning number, we get the message warning number 2. Iterating, so we increment I, we do our comparison, and then we step inside, making warning number 3 because I is 3. And the same for 4, we do our comparison, print it out, and 5, print it out, and then once I becomes 6, we do our comparison, so 6 is no longer less than or equal to 5, so we do not step inside our loop, and we just finish our function. We can do a lot of cool stuff using the variable I, because it keeps changing as the loop increments. However, you have to be very careful not to change the variable I, because it's still used to control the loop. Let's have a look at an example. This loop here starts with initializing I to 1, and it keeps iterating as long as I is less than or equal to 3, and it increments I by 1. The first thing it does is it takes away 1 from I, and it prints out I. If we think of what this loop is doing, it obviously loops from 1 to 3, so it goes 1 to 3, and then we're subtracting 1 and we're printing I, so maybe we can think that this would print 0, 1, 2. Well, let's trace it and see what we get. First thing we do is we initialize I to 1, and then we do our comparison. Is I less than or equal to 3? Yes, it is. So we step inside, and then the first thing we do is we change I to be equal to I minus 1. So that makes I 0. Because we subtract 1 from I, and that was 1, and we update I to become that subtraction, which is 0. And then we print out I, which in our case is 0, so the output becomes 0. We end our loop, we go back up here. The first thing we do is we increment I, making it 1, and then we do our comparison, I less than or equal to 3. Yes, it is. So we step inside our loop, and we do this again. We subtract 1 from I, which was 1, making it 0, and then we step into the print line and print out 0. We finish our loop, we go back up here, we increment I to become 1 again. And of course 1 is still less than or equal to 3, and that keeps on happening over and over and over. This actually is called an infinite loop, because this loop would never end. It would keep repeating itself for infinity. You have to actually stop your program and force to quit it. Infinite loops are quite common if you're not careful enough. So feel free to use I as part of your program inside the loop, but always be careful not to change it to something that is not in your control. In this case, the problem was because we were assigning a value to I, while I was still being used as our loop counter. And because every time we incremented and then decremented again, I would always iterate between 1 and 0, and it would never end, because it would never reach 3. However, if we implement our loop this way, then we're safe. Let's have a look why. The only change we did is we created this new variable x, and when we subtract 1 from I, we actually store it in x rather than update the variable I. Let's trace this and see what happens. I starts by 1, and then we check if it's less than or equal to 3. It is, so we step inside, and then we update the variable x to be I minus 1. So 1 minus 1 is 0, so x becomes 0. And then we print out x. So our output becomes 0. We finish this iteration, so we go back up, we add 1 to I, and notice here because I hasn't changed, so we're adding 1 to 1, and it becomes 2. 2 is still less than or equal to 3, so it's true, so we step inside our loop, and then we update x to be I minus 1. I is 2, so x becomes 1. And then we print out x, which in our case is 1, so we print out 1. This is the end of this iteration. We go back up, we increment I to make it 3, and then we do our comparison, and in this case it's still true. So we step inside our loop, we update x to become 2, and then we print out x here. We go back up, we increment I, making it 4, but 4 is no longer less than or equal to 3. So we're not going to even step into the loop, we're not going to update x, and we're not going to print out anything. This is the end of the loop. The reason this was safe compared to the infinite loop we had earlier is because we were not updating the variable I. So the lesson learned from this is that we are allowed to use I as a variable as long as we don't update it. Let's see another example that's also safe. In this example, the only thing we're doing inside the loop is we're saying print line I times 2. Notice that we're not updating I, we're just multiplying it by 2 as we're printing it out. So instead of printing out I, we're printing out twice I. Let's trace this program and see what's happening. The first thing is we initialize I to be 1, and then we compare it if it's less than or equal to 3, which is true. So we step inside, we print out I times 2, which is 2, because I is 1. We reach the end of the iteration, we increment I to become 2. The reason that this is okay is because I hasn't changed. So when we reached our increment, it was still 1, so it jumps up to 2 as normal. And then we do our comparison, I is less than or equal to 3, yes it is, so we step inside, we print I times 2, I is 2, so the output would be 4. And then we go back up, we increment I to become 3, 3 is still less than or equal to 3, so we step inside, and we print out 3 times 2, which is 6. We increment I, which makes it 4, but 4 is no longer less than or equal to 3, so that's false, and we don't print anything. Once that condition becomes false, we do not step into the loop, and we just exit. So there we go. It's really handy when we use the variable I, or whatever the loop counter is called, inside our loop. Remember that you could also do this with while loops, of course. Just be very careful not to change it. Let's have a look at how we can actually use loops to calculate stuff for us.